Chapter 8. Simple Equations. Introduction. We have studied that an algebraic expression contains some variables and constants. The mathematical statements can be written in the form of algebraic expressions. For example, 5 less than twice a number x can be written as 2x minus 5. 1/6 of a number x can be written as x upon 6. 3 times of a sum of number x and 7 can be written as 3 into, within brackets, x plus 7. Now, consider the following statements. 6 more than a number x is 13. Can be written as x plus 6 is equal to 13. 3 upon 2 times a number n is 15. Can be written as 3n upon 2, which is equal to 15. A number y divided by 7 gives 5. Can be written as y upon 7, which is equal to 5. In each of the above statements, the symbol equal to is equal to appears. A statement involving symbol is equal to is called a statement of equality. Equation. A statement of equality which involves one or more variables is called an equation. The expression to the left side of the equality sign is the left-hand side LHS, and that of right side to equality sign is known as right-hand side RHS of the equation. Linear equation, an equation in which the highest power of the variables is 1, is called a linear equation. For example, equations 2x plus 4 is equal to 6, y upon 3 plus 1 is equal to 2, and 2z plus 5 upon 2 is equal to 37 upon 2 are linear equations. Here in this chapter, we shall study the linear equations having only one variable or unknown quantity. Solution of an equation. The value of unknown variable which satisfies equality of both sides of the equation is known as the solution or root of the equation. Let us verify that x is equal to 3 is the solution root of the equation 4x plus 6 is equal to 18. LHS is equal to 4x plus 6. For x is equal to 3, LHS is equal to 4 into 3 plus 6 is equal to 12 plus 6, which is equal to 18. This is equal to RHS. Hence, x is equal to 3 is the solution of the equation 4x plus 6 is equal to 18. Solving an equation. To solve an equation is to find a value of the variable which satisfies the equation. We have already learned to solve an equation using trial and error method and systematic method. Trial and error method. Examples. Find the solution of the equation 2x plus 3 is equal to 15 by the trial and error method. Solution. The given equation is 2x plus 3 is equal to 15. LHS, RHS. 2x plus 3, 15. If x is equal to 0, 2 into 0 plus 3 is equal to 3, not equal to 15. If x is equal to 1, 2 into 1 plus 3 is equal to 5, not equal to 15. If x is equal to 2, 2 into 2 plus 3 is equal to 7, not equal to 15. If x is equal to 3, 2 into 3 plus 3 is equal to 9, not equal to 15. If x is equal to 4, 2 into 4 plus 3 is equal to 11, not equal to 15. If x is equal to 5, 2 into 5 plus 3 is equal to 13, not equal to 15. If x is equal to 6, 2 into 6 plus 3 is equal to 15, is equal to 15. Thus, for x is equal to 6, LHS is equal to RHS. Hence, x is equal to 6 is the solution of the given equation. Systematic method. The trial and error method is time-consuming. The other method resembles the process of a balance used for weighing. Rules for solving an equation. Rule 1. If same number or term is added to both sides of the equation remains same. For example, x minus 2 is equal to 7. If we add 2 to both sides, we get x minus 2 plus 2 is equal to 7 plus 2. This implies x is equal to 9. Equation x is equal to 9 is similar to x minus 2 is equal to 7. Rule 2. If same number or term is subtracted from both sides of the equation remains same. For example, x plus 4 is equal to 9. This implies x plus 4 minus 4 is equal to 9 minus 4, subtracting 4 from both sides. Rule 3. If we multiply both sides of the equation by the same non-zero number, the value of both sides remains equal. For example, x upon 5 is equal to 3. This implies x upon 5 into 5 is equal to 3 into 5. Multiplying both sides by 5, this implies x is equal to 15. Rule 4. If we divide both sides of the equation by the same non-zero number, the quotients are also equal. For example, 6x is equal to 18. This implies 6x upon 6 is equal to 18 upon 6, dividing both sides by 6. This implies x is equal to 3. Example. Solve the following equations. X plus 6 is equal to 13. Solution. X plus 6 is equal to 13. This implies x plus 6 minus 6 is equal to 13 minus 6, subtracting 6 from both sides. Therefore, x is equal to 7. Example. Solve the equation 3x minus 6 is equal to 0 and check the result. Solution. We have 3x minus 6 is equal to 0. This implies 3x minus 6 plus 6 is equal to 0 plus 6, adding 6 to both sides. This implies 3x upon 3 is equal to 6 upon 3, dividing both sides by 3. This implies x is equal to 2. Solving linear equations by transposition method. While solving the equations, we add or subtract the same number or term on both sides of the equation. Transposing a number, that is, changing the side of the number, is the same as adding or subtracting the number from both sides. While changing the side of a number or term, the sign of the number or term has to be changed. That is, when we transpose a positive number or term to the other side of the equation, the sign of the number or term becomes negative. Similarly, when we transpose a negative number or term to the other side of the equation, the sign of the number or term becomes positive. On transposing, positive changes to negative and negative changes to positive. Let us take an example to solve the equation. 3x minus 6 is equal to 9 by two methods, adding or subtracting on both sides. 3x minus 6 is equal to 9, adding 6 to both sides. This implies 3x minus 6 plus 6 is equal to 9 plus 6. This implies 3x is equal to 15. Transposing, 3x minus 6 is equal to 9. Transposing minus 6 from LHS to RHS. This implies 3x is equal to 9 plus 6. Minus 6 changes to plus 6. This implies 3x is equal to 15. 2x plus 3 is equal to 15, subtracting 3 from both sides. This implies 2x plus 3 minus 3 is equal to 15 minus 3. This implies 2x is equal to 12. Transposing, 2x plus 3 is equal to 15. Transposing, plus 3 from LHS to RHS. This implies 2x is equal to 15 minus 3. Plus 3 changes to minus 3. This implies 2x is equal to 12. Examples. Solve. 4x plus 20 is equal to 12. Solution. We have 4x plus 20 is equal to 12. This implies 4x is equal to 12 minus 20. Transposing plus 20 to RHS. This implies 4x is equal to minus 8. This implies 4x upon 4 is equal to minus 8 upon 4, dividing both sides by 4. Hence, x is equal to minus 2. Applications of simple equations to practical situations. We have learned to change mathematical statements into equations and also solving simple linear equations. Many problems are involved in our daily life, which can be solved by means of equations very easily. With the help of known and unknown numbers based on statements, equations can be formed. On solving the equations, we get the solutions of the problems. First of all, we write the equation based on the given condition. Then, we solve the equation with the laid down procedure. Examples: 1/4 of a number decreased by 7 gives 5. Find the number. Solution: let the required number be x. According to the equation, 1 upon 4x minus 7 is equal to 5. This implies 1 upon 4x is equal to 5 plus 7, transposing minus 7 to RHS. This implies 1 upon 4x is equal to 12. This implies 4 into 1 upon 4x is equal to 4 into 12, multiplying both sides by 4. This implies x is equal to 48.